Hello everyone, today I am going to talk about what is Docker, how Docker works, a specialization of Docker, and at last I will show practical on Docker. But before understanding Docker, let's understand how applications were built even before Docker existed. Because the Docker itself is released in year 2013 and the applications were made before 2013 also. So let's go back into year 2000 and understand how the application were made. So let's suppose I have an requirement to build a banking application. So at that time for creating any application we needed a server, or we can say a laptop. And then now I have bought a physical server. This is my physical server which I bought. Physical server. And for making a banking application, what we need, like suppose we want to create a banking application, so there we will be need we want to create we have to decide in which language we have to make an application, what and all languages we are going to use for creating a website, or what language we are going to use. Then only like what are the take a step we need to create this application. So suppose I want to create my application in Python. Python was released in year 1991. So Python I want, then which operating system we need. So let's suppose that time we have Windows operating system, and again we have to code in HTML, some language for creating HTML, CSS. So yeah, now I have created an application in this physical server and my application is running perfectly. Okay, I have created. But later what I want to make a new application, like again I want to create a application for some ticket booking. So again I have to go and buy a new physical server. So again this will cost me. So for making every new application we needed to buy a physical server and it was costly for me. So now the question can arise, why can't we build a same like a different application on the same physical server? So I will tell why we can't build say more than one application in the same physical server at a time. So suppose I have created an application, Python banking application, which is sorry, which is running in port, like it is a web application, and I have hosted and it is running in port 8000. And again we have created a different application, like suppose a Java application. This is my Python and this is a Java application. And again some developer has given that the oh no we port 8000. So this is a mismatch. So only one application can run on port 8000, because two applications can't run on same port. So this was one issue, and there were some more issues which I will talk later. But then what we decided later, no, like uh, because we have to buy a physical server, it was costly. So what we will do, the concept came of a virtualization. So in this virtualization, what we were doing, we were buying a big physical server. Let's say suppose I have 64 GB RAM server I have bought, and I have some 32 core CPU, or let's say 16 core CPU. And in that, what we have done, we have installed a hypervisor in my bare metal. Like I have, this is my physical server, physical server, and here I have installed a hypervisor. So hypervisor is a virtualization technique. So for virtualization, we need to have a hypervisor, and hypervisor is of type two type, like type one hypervisor, type one, type two hypervisor. This I will explain later in detail what is this type 1 hypervisor and type 2 hypervisor. Now my hypervisor is installed in my system. Now what we will do, like in this I will create one virtual machine. Virtual machine, I have created one virtual machine. This is my second virtual machine. Let's suppose this is my virtual machine 3. And now here I will create a Python application, Python app, Java, Java, and some C++. So now what VM is doing, it is isolating the environment. Now if I will run the Java application on port 8000, so and the Java application is also running on port 8000, so it will not make a conflict and the application will run successfully in both the VM, and also the cost of my server will not uh, be increased, because we don't need a different server to run a different application. But the limitation of this was that, like in physical server, for creating this a separate virtual machine or something, we have to have a different OS for it. Like suppose in VM1, we need a OS Windows, and again we have to install Python here, Python, Python any version 3 point something at that time, and again we needed some web server to host this application. So it was a time consuming, because let's say suppose I have a one server, this server, and here I have created so many virtual machine. Like let's say suppose I have created 8 virtual machine, and virtual machine 1, it has a different OS, virtual machine 2 has a different OS, and so on. Like virtual machine 8 will have different OS, and this is one physical server. So server is having, physical server is having RAM of 64 GB. So the usage of this 64 GB RAM, it can't go beyond this. Like if you think like I've created a VM1, so VM1 can't go, like if VM1 has used 8 GB of my physical machine, VM2 has used 8 GB, 8 GB, VM3 8 GB, or something like 16 GB has VM3 used, VM3, and VM4 has used again 16 GB. So total allowance is 32 and 16, 48 GB. And some other VM I am having 5. It is also using 16 GB. So it can't go beyond 64 GB. And booting of one VM, it was taking time. Like because whenever we want to start a VM1, so starting of VM1 will take some time, because it will boot up first it will boot OS, like if you have operating system, then it will again create an environment, and so it was a time consuming. So what the so to for removing this limitation, what there were the Linux engineer, what they have done is that they have came up with a virtual concept of containerization, or we can say that uh, well, like uh, uh, we can say Like Linux engineers thought, Linux engineers thought that do we really need a separate separate OS for running the application? And the answer was no. So what they does, like, because most of the application only needed for running most of the application, it needed like some processes for running application. We need processes, libraries, runtime, and isolation. So they came up with the concept of container container or containerization. So now what does containerization mean? Containerization is simply what uh, it is doing, what we were doing in this hypervisor. So containerization is also doing the same thing. Like it is creating a separate environment. Like what hyper does it, hypervisor as well. It has created a separate virtual machines instead of creating a separate virtual machine. What container will do? Container will create a separate isolated environment, and but they will use the operating system of the same physical server. So in this way, the headache of like, the the problem was solved solved because we now need not to install separate OS in the physical server. So now the idea of containerization is like I have one host operating system, host host you can say, or physical physical server. In top of that, I will have a container engine, and container engine will create a separate environment for my application, not the OS. So in this, a separate application is running app one. It is also running on port 8000. App 2 can be also running on port 8000. App 3 can also be running on port 8000. And every like app can have a different languages. Like this is my Python, it is in Python, Java, or this application is written in Go. So there is now this container engine will use the operating system of this. Now let's talk about what does what is Docker doing. The Docker is doing nothing but a Docker is using the uh, container engine only to separate the environment. How it is doing? Like what Docker does is it was like it is also creating a separate environment using a container only. Like it is packaging our application. Like if I have created an Python, so it will always Docker will always Docker is a container engine only. Container engine it will work on. Suppose I so Docker will what Docker will do. It I have written a Python application. So Docker will package all the libraries, all the dependencies, the dependencies which are required to run the so now we can package our application using a Docker and we can run on top of this. Hence the same concept, Firebase, Java, Python, but Docker has packaged it. Now let's talk about, let's go to the first key, how Docker works. I have explained what is Docker. Docker, let's talk about what is Docker, or I will give what is a Docker. What is Docker? Docker is a tool which is used to package all the required libraries, dependencies, dependencies, which is used to package all the required libraries to run our application and will create a container. Basically, and container is nothing but a container. Container is a separate environment. So, so now let's talk about how Docker works. Docker works by using containerization to package all of its components, components required to build is suppose like open a code library and settings into a single unit called container. But in case of a virtual machine, we have to install separate OS for running the some application. Now let's talk about the workflow of Docker. Workflow, workflow of Docker. So first of all, for using Docker, like uh, the process of using a Docker, we have to the process of using Docker. We first need to install Docker engine in our system. First step. Then then we then we will create a Docker file. Like it does it does not contain any extension, don't contain any application. Docker is basically file is basically a set of instruction, a set of instruction which we write in this file to run our application. And when the Docker file is created, like from Docker file is created, we have to build it. And build Docker file we have to build, and after building this Docker file we will get an image, and this image is a like this is a ready-made snapshot to run our application, and from image we can run our Docker container. Docker container is nothing but a running image. Okay, so now let's go and do some practical, like how we can write a Docker file, how like we can create one. I will show like I will write a simple Python application. We will run it in our local server, and then we will be going to run in EC2 machine where Python will not be installed or something. So now this is my local. I have opened a Visual Studio for coding. Now here I will see if my Python is installed or not. Python dash dash version. So yeah, Python is installed in my system. Now I have to run any Python application, I will write a Python, like, let me write a simple Python application for, like, I will create a file main.py, and inside it I will just create an application print hello world, or let me write a Python program to add two numbers. So I will take an input name equal to int input, enter first number, and to insert second number, and then I will do print the sum. So this is my simple Python application, and for running this I will do a Python and name of application. So the first number 1, 2. So yeah, I am getting the output as the sum of number is 3. Now how to dockerize this? Like, if the same application, if we want to run in any application, so I have to create a Docker file. So, and the name of the, like, Docker file itself will be a Docker file. And first, I have to explain, for writing a Docker file, what all keywords we need. So Docker file is basically are of two type. Like, for creating a Docker file, not Docker file. So image are of two type. Docker file for creating an image. So image are of two type. One is base image, and one is custom image. Custom image. So base image are basically image stored in Docker hub, and the custom image which which we can or user which we can create by combining the base image, finding base image. So suppose I want to create a Python application, so I will be needing a Python in my system. So I will import a base image from Docker Hub. So for importing a base image, we have to we use a from keyword. So I will show how we can import this image from a Docker Hub. So Docker Hub is nothing but a registry where the image are stored. So I will go to Docker Hub and search for Python. Like, suppose here my Python version was 3.13.13. So same should go into my, so I will go to this explore and search for, here you can search Python. Okay, Python. Yeah. So, and in this Python you have to go and check for images, and here I will search for filter by like 3.13 or 3.13. No, I am not getting an option. Alpine, Debian, Python 3.13. Or you can go to the repository, explore, go to this Python page, and in Python go to tags, and in tags page do a search like 3.13, and you can pull any image, like see there are 3.13 trick C, so it will be taking 393 MB per creating an image out of this base image. And this one is this simple task. This is taking a 2.11 GB, so it will be a very big image. But I need a smaller image, so I will go with slim or option. I will get a Python 3.13.13 dash slim. Go to this page. Two point one three. Yeah, now it will show all the 3.13 later. And this is the small slim, so you can go with either this option or this slim, the slim option. So I will go with this option. And what we have to just write like Python, copy this, and from I will go to from just pick it from Python. Okay. Now what I am going to do, I like I have to copy this file in my image like main.py, and for running container also like where all my code will be available, like for uh, copying all the codes from our local to in our container, we have to give a directory name. So for giving a directory name, like where all my file will be going, if we are copying from our local to a container, so we have to give a keyword work directory, and in work directory I'm giving okay app, and copy this all the code like all to my app, and I am just simply writing a command key. Okay, this command I have to give. In command for running what I have given, I have given Python main.py. So in command also like cmd is a keyword, and inside that we have to give a square bracket, and in curly double quotes we have to give a the command which we need to run our application. So I'm giving Python main.py and save it. Now my Python Docker file is saved, and to build an image out of this, we have to give a command like Docker. First, we have to see if my Docker is working fine or not. So working, I have to see Docker version. So my Docker is like not running. So I have to first open the Docker in my system. So go with the search it and go with the Docker search, because I have shown like how to install Docker in our system. So now, if I will check Docker version, so it will take some time in my system to start a Docker desktop, because it takes time. It is a huge application to start. So let's start again. Meanwhile, I will create one server in EC2. So to show that the same application, if we want to run in a different server, but there we don't need to install any Python. So I will launch one server in EC2. I will name the server as it is a Docker. Docker. I will take a Ubuntu machine, and let's say my key pair. I created one key pair, and just I will launch it. So now Docker is starting. Till now my Docker is not started. Start. Yeah. So now my Docker is starting in my local. Now I will check the Docker version. So now Docker is saying, and to build the image, I have to type Docker build -t. So I will talk about this command also later, but for now we have to just give a Docker build -t. -t means what name we want to give to the image. So I am just what I'm doing is sum. So I will give the name of this my application or image as a sum, and what should be the version of this. So I will give now as a latest, and from where this Docker will build means from where my Docker file will be taken up to build this image. So my Docker file is inside this folder only, not this. So I have to go inside this Docker in my terminal, then only we can build. So you have to go inside this folder, like where your Docker file is uh, kept. So and now we have to build it is Docker build hyphen t some latest and dot basically means in this folder only we are having my Docker file, and just enter it. Now it has started building my Docker image. So let's check. To check a Docker image is built or not, check if a Docker images. And yes, I have got one, this Docker images. And to run this, I have to give a Docker run hyphen, sorry, Docker run hyphen dit. Basically, dit means detached it's like a run, Docker run hyphen dit means it is in detached mode. Detached, and this is interactive terminal, and then we have to give the name of our image document some and latest. So from this our container will be ready, container will come up. Let's go and execute this command docker run dit some one. Sorry, this spelling mistake, latest. So my container is running. So for seeing this container, if my container is up and running or not, so we have to do a docker ps. Now my container is running. So now you must be wondering, so how to run this application? Like how will you get this output? My docker is running, my container is running. So for running this application, we have to go inside this docker for exec hyphen it and the container id, and we are going to use a bash like it is a bash is like a shell script, so in that way it's going. So certain hyphen it docker execute. So basically here we don't need to give the see the command to insert into a docker container. Let me google it. Command to go inside docker container. It is docker container. Yeah, I have written the same docker exec hyphen it, but why it is docker ps. Let me check docker ps. It is there, and I am giving docker exec hyphen it container name hyphen it. Here is my container is working or not. So here my application in Docker desktop also we can go and see my application is. So I will go inside this container, exec into it, and basically I am inside this, and I will in Python main dot py. The first number, that is the number. So yes, it is running inside my container. Why it is not running here? Docker ps. Docker is running. Docker exec hyphen it, and this dash also given. Or let me go into Docker exec hyphen it, and this message container. So I have to create container ID. Yeah, now I'm inside my container. Now here, if I will see the Python dash version, here I've got the same Python version, Python 3.13. And now I will run the application. Python main dot py. Just one, two. So yeah, now and I want to see if my code is copied in this. Like this is my working directory. If you see last app, so in this, if I will ls, here I will get both my application like main.py and dockerpy. So what does a let me see the content of my main.py file. So it is the same which I have written my uh, in my file, and here also in this docker also it is containing. Now let's go and run the same application in my EC2 server. So my instance is launched, and let me connect to this. For connecting I have to SSH. I have done this. So I will make a like a separate video like how to create EC2 and how to connect through it. Now I have to go to my cd slash home slash, and here I will be having my pem file like test.pem file. So it will be used for connecting to my server. So yes, now for running the same application in this server, this is my different application, not my local. This is my app connected to my EC2 server, and here if I go and check Python that version, Python is not installed, but we want to run this application via Docker. One thing we can do, we can install a Python directly and run this application. But suppose there are more libraries which needed to be installed. Like for running a Python, this is just a simple application where no libraries are installed. But if you needed more libraries, like later will use fast API, uh, uh, Pydantic library, so that there will be a huge number of libraries, and manually installing in this server it will take so much of time. But to avoid this, what we will do in Docker file, or we will create one requirement.txt file, and in that txt file we will uh, write all the libraries needed to it, and in Docker file we will again create one command to install through that requirement.txt file. But for now, what we need to, we have to install Docker in our uh, EC2 server. So let's go and check how to install Docker. So for that we will just go and search on Google, install Docker in Linux. Yeah. So first link which will got installed Docker engine on Ubuntu, because I am running a Ubuntu machine. So see, first of all we have to set up a Docker apt registry. So we don't need to do anything, just copy this command, paste it. Now when it will be installed, we will have to, okay, now it is asking for, do you want to continue? Yes, I want to continue. And now we have to run this the second command which we are installing. So okay, again continue. Yes. Now I want to see if my Docker is installed in this VM or not. Docker dash dash version. So yes, Docker is installed in my system. But if we want to go and build a Docker, like first we have to create one again file. So for this, for running the same application, what we'll do and I will make a directory Docker check check Docker check I am doing, and I will go inside the directory Docker check ls. I don't have any file here, so I will create the same file which I created in my local. Um, so for creating the same file, so I have to create using a vi editor, vi main dot py. Okay, and in this main dot py, I will uh, copy paste the same uh, code which I written in my local, and I will save it wq. Say I have saved it, and again I will create one docker file, and in this also I will copy paste the same code which I have written in my local. Okay, wq. But now if I will go and build this docker file, docker build -t, same which I have given in my, like, uh, in my local. I'm taking this from my local -t some at, and my docker file is in this. So it will give an error, permission denied. Why? Because this Docker, I have created Docker file, and this and this Ubuntu user is not able to access this Docker group. So what we have to do, we have to add this Ubuntu user in my Docker group. So for adding this in my uh, Docker group, what we have to write a command, sudo user mode hyphen append to my group, and append to my group Docker and dollar user. Now, if we want to see my group, if my uh, like Ubuntu user is added in my Docker group or not, so we have to do cat /etc/groups. Sorry. So you can see this is the Docker group and Ubuntu is added. Now, if we want to build this Docker file, we have to again run the command docker build, but we are getting the same error. Why? Because now we have to do reboot our system. So for rebooting our system, we have to give and write a command sudo re. Now rebooting will take some like 30 seconds of time. So I have to again go and connect this. So yeah, it will take some 10 to 20 seconds of time to connect because I have just rebooted. So it will be rebooting. So now I have again connected. Now if I will go and do the same command but first I have to go inside my cd docker check ls. Now my file is available and now I have to build a docker build and then now it is building. And now if I will check like if my Python is installed in my like this server or not, Python that's the version. So Python is not installed, but to run this application, like we needed a Python. But now I am going to like run this application using a Docker. So what I have got a Docker image, Docker images. I will see. Yeah. So now I have got a Docker images, and from these Docker images, I will run a container. So for running the images, the command will be again same Docker run hyphen detach itt and some app. So my Docker has just started my container. Let's see if my Docker container is running or not. So yeah, my Docker PS is running, and now I want to go inside this container to see if my application will be running or not. So we have the same command Docker exec hyphen it container ID. Copy this container ID and pass. Now I am inside my container. You can see everything is copied in my app. I have when I will do a ls command, it will list my file, and if I want to run the application, the Python main.py. So yeah, now my application is running perfectly, and I don't need to install a Python in my server also. If I will come out of this exit and I will see this Python is installed, Python dash version installed or not. So no, Python is not installed, but my application is running through a Docker. So yes, this is the like I can say it has packaged all my application into a image, and through image we can run our application. So yeah, this is all about today. Going further, I will also talk about this keywords. They are like keywords, a fixed keyword which we will be using for creating this Docker file. So thank you for today. And if you like my videos, do consider liking it, subscribing it, and if there are any suggestions, comment it, and also share with any friends. So thank you.